As we move on now, we've discussed it before here on Market Journal, but recently we had the chance to see it in action out in the field. UNL researchers expanded a project this year as they work to autonomously plant using a machine that they call FlexRow. Market Journal's Mike Straub has this story with some footage from the field. Mike?
For the past several years, a team at the University of Nebraska-Lincoln have been working on a new piece of technology that is geared towards making field maintenance much easier. Their solution is an innovation called FlexRow. This is an unmanned ground vehicle that can distribute seeds, chemicals, and fertilizers.
We have a multi-purpose robotic platform called FlexRow, and like I said, it's multi-purpose, so we could do planting, we could do phenotyping, and also spraying. So at Rogers Memorial Farm, we kind of demonstrated how our planter row units work.
FlexRow is an important robotic tool that can perform targeted operations while saving cost and implementing climate-smart agriculture. Spraying and fertilizer application are currently being tested.
We are going towards climate-smart agriculture, which is really important, and robotic tools and technology tools have a big role to play. So we see FlexRow as one of those important robotic tools that can do very precise operations in the field while saving costs. If you think about targeted spraying, so only spray where things are needed instead of spraying throughout the field. Fertilizer application is another one we're exploring, where can we do very targeted fertilizer application.
The FlexRow is intended for multi-purposes and is built to be modular. It can collect data through onboard sensors used to measure such things as reflectance, plant height, temperature, and humidity.
This machine has been in development since 5 years, so a couple of master's graduate students worked on it. Now we have a third graduate student working on it, and when we started, our goal was how can we develop a field usable robotic platform that is modular, but also it should have the ability to do multiple operations. So we have 6 computers on this machine that exchange information, or a network called CAN bus, so that we can do very precise operations. And also we're using different camera technologies to look at green pixel fraction, which is basically in an image how much greenness is there. We're using spectrometers that tells us nutrient deficiencies. So there's a lot of sensor technologies that we're using, and using all that information to make decisions so that we can very precisely do site-specific management.
While someday the FlexRow could be a part of everyday use for farmers and producers, developing farmer-friendly robotic solutions that are easy to use involves a lot of obstacles.
So we are at this is a research prototype, so taking this to an actual product that farmers can actually use is a big hurdle, So how do you make a product out of a prototype, right? So that's very important, So exploring if some of my students, they want to do this as a startup company, that is one way to do it, Take the intellectual property we developed and make it into a company. So that's one avenue. I think the important point is how can we develop farmer-friendly robotic solutions is what is important. How can we give a system to a farmer that is not too complex, and it is easy to use. So there's a lot of thought that needs to go into it. So it's not like research, right? So in research, we are aware of the system, how it works. If there's a problem, we know how to troubleshoot it. But when we're giving this system to a farmer, it needs to be really well thought out. But I would say maybe in the next 3 to 4 years, this type of technology will be available.
FlexRow could be a product which, in the future, could aid researchers with a few acres of plots to farmers with thousands of acres. Before this can happen, however, there are some hurdles to overcome. Reporting for Market Journal, I'm Mike Straub.